Now, dear students, we are in the next very important segment of this chapter, and it is about the Heisenberg's uncertainty principle, or simply it is called as Heisenberg principle. It is also called as Heisenberg's uncertainty principle. Now, this principle is the theme or the essence of modern physics and chemistry, and rather the complete summary has been based on different laws, and one of them is Heisenberg uncertainty principle. So first we'll see what is the statement of this principle. So the statement is very simple. It is impossible to find out the position and momentum of a particle like electron with absolute accuracy simultaneously. See carefully. Meaning is that we cannot find out the position as well as the momentum. Momentum means the product of mass and velocity of a particle like electron with absolute accuracy simultaneously. Means with 100% accuracy, we can either find out the position or the momentum or velocity. Both cannot be found out. See how. So, according to this principle, it is impossible to find out the position and momentum of a particle like electron with absolute accuracy simultaneously. Means both cannot be found out together. Other way is that we can have either the absolute value of the exact position of an electron. Exact position of electron means the exactness, the accuracy, or the velocity of an electron, and never both. We cannot find out both with absolute accuracy. So this is the statement, and its mathematical point is that delta x into delta p is greater than equal to h upon 4 pi. This is very simple mathematical relationship, and see this delta x, it is uncertainty in the position of electron. This uncertainty in the momentum, and h, h is what? H is Planck's constant. So it is the point to note that electron is very small particle. So either we can have the absolute value of the position, or we can have the absolute value of the momentum or velocity. Why? Or we may write down delta x. Now mass is remain constant. So this the change in the velocity greater than equal to h upon 4 pi. Some ways, some persons also write that delta x, delta p nearly equal to h upon 2 pi, nearly equal to h upon 2 pi. So this is the basic information about the statement and the mathematical approach. Now in the next part we will see what is the region. What is the region that either we can have the exactness or accuracy in the position. Accuracy in the position and the accuracy in the momentum. Either only one is possible, not both together. Now see why. Now I'm going to explain about the reason behind this type of results. Either we can have the absolute value of position or the momentum or the velocity. Now see how. Suppose if there is an atom and in atom there is an electron, and children, you know, electron is very small in size. So what to do? We have to see the electron. The position and the velocity can be ascertained, can be found out only by the use of light radiations having suitable frequency. We cannot see an electron or similar particle in low light or ordinary light. Suppose here in the room the light is not so strong, electron is very small, you have an idea. So what to do? We have to use light radiation of slightly higher frequency. Or you have seen in the spectrum that this wavelength and the frequency, they are, wavelength and the frequency, they are inversely related. Wavelength and frequency are inversely related. It means if you use light radiations of a stronger frequency, so what will happen? There will be the change in the position. Now see how. First condition, if we use light rays of higher frequency, light rays of higher frequency, so what will happen? There will be the impact. These are the light rays. So what will happen? It will start moving faster. Electron will start moving faster. So in this condition, we can have the exact position. We can have the exact position and not exact velocity. This is the point. When you use light radiation of high frequency, more energy, so it will displace the electron. So velocity will be changed. We can have only the exact position. Now second, if we use light rays of lower frequency, then we can see only the moving electron, that is the velocity. Velocity can be exact because we are unable to judge. We are unable to judge when the when the lower frequency, lower energy rays are there, so we can have only the exact velocity of electron and not the position and not the position. This is there. So this is there. Now next we'll see about the implication in our daily life. So children, there is no effect on our daily life. It has no effect on our daily life. Why? Because we do not discuss with the electrons in daily life. No doubt, electrons, protons, neutrons are integral part of our life. In every field there is. Suppose we are using electricity or anything, or microwave or TV, radio, whatever thing. But we are not dealing with the electrons, protons, or neutrons, or any subatomic particles directly. Instead, we are using the application part. What we are using the application part. So what we can say that there is no effect on our daily life. So it has not any relevance in our daily life. So this is all about the Heisenberg certainty principle.